Welcome to the second session of Orthographic Projection, Unit 4 of Computer Aided Engineering Drawing. So in the previous session, we studied what are the various methods of projection, and in detail we studied what is orthographic projection. So in this session, we are going to see what are the guidelines that are to be followed to draw the orthographic projection, and also we are going to draw the orthographic view for a given isometric view of a component. So this orthographic projection is known as the multi-view drawing. So what is orthographic projection? A orthographic projection is a 2D, two-dimensional representation of a three-dimension object. Okay. So orthographic projection is nothing but the two-dimensional representation of a given three-dimensional object. This orthographic projection is also known as the multi-view drawing. Why it is called multi-view drawing is we are supposed to draw more than one view of the given component in order to indicate all the interior and exterior features of the given component. Usually, the front view, the side view, and the top view will be drawn for any given component in the multi-view representation, that is the orthographic projection. So let's see how the different solids are represented in the multi-view drawing. Okay, so this is a pyramid. The pyramid is the vertical pyramid is represented as a triangle in the side view as well as in the front view, and it is represented as a rectangle with intersecting diagonals in the top view. Similarly, the cylinder is represented as a rectangle in the side view as well as in the front view. This width of the cylinder will be equal to the diameter of the cylinder, and the height will be equal to height of the cylinder. Similarly, the cylinder is represented as a circle in the top view. So this is how the combination of prism and cube is represented in the multi-view drawing. So a rectangular prism is represented as three different rectangles in the front view, top view, and the side view of different dimensions. And similarly, a cone is represented as a triangle of base diameter equal to the diameter of the cone in the front view as well as in the side view. So the cone is represented as a triangle in the front view and the side view, and it is represented as a circle in the top view. The sphere is represented as a circle in all the three views. A truncated cone is represented as a truncated triangle in the front view and the side view, and two concentric circles in the top view. A partial sphere is represented as a circle in the top view and semicircles in the front and the side view. This is how the combination of a prism and a partial cylinder is represented in the multi-view drawing. And also the combination of prism and a cylinder is represented as shown in this diagram. So in this, the cylinder is in the top view is represented as a circle. The diameter of the circle will be equal to the diameter of this cylinder. Similarly, the prism with the hole is represented like this in the multi-view drawing. This the hole is represented as a circle in the top view, and this hole is shown as the hidden lines in the front as well as in the side view. So coming to how the normal surfaces appear in the three different views of a component. So if you observe, I have a stepped block. In this stepped block, the direction, this is the direction of the side view, this is the direction of the front view, and this is the direction of the top view. So if I observe from the side view, I can see two rectangular surfaces that are colored in red in color. So how the normal surfaces are represented is the normal surfaces appear as an edge in the two principal views, and they appear as a surface in all other principal views. So coming to this diagram, so if I observe from the side view in this direction, that is the direction of the side view, I can see two rectangular surfaces, one above the other, that are colored in the red color. These two surfaces are represented as an edge in the front view, as well as in the top view. Okay, so this is the side view. So this is the side view of the given component. So I'm observing it from the right side. So this is the right side view. So that will be drawn on the left profile plane in the first angle projection. So in the side view, we are going to see two rectangles. Okay. So these rectangles are represented as an edge in the front view. So this is the front view of the component. So this top surface in the side view is represented by this edge in the front view, and this bottom surface in the side view is represented as this edge in the front view. Similarly, in the top view, this plane surface, the above plane surface in the side view is represented by this vertical edge, and this plane surface of the side view is represented by this vertical edge in the top view. And coming to the inclined surfaces, these inclined surfaces appear as an edge in one of the principal view and appear foreshortened. That means they are not to the true size in all other principal views. So consider a block. Okay, this is the one of the surface of this block is the inclined surface. So this is the inclined surface. So this is the direction of the side view. This is the direction of the front view. So this inclined surface is represented by an edge in the front view, this inclined line in the front view. So this is the front view of the object. This inclined surface is represented by this inclined edge in the front view. Okay, in the top view, okay, now it appears in the top view. This is the top view of the given component. The inclined surface is represented by this surface that is colored in red color in the top view, and it is foreshortened. That is, it is of lesser dimension compared to its actual dimension. It is not to the true size, and it appears to be foreshortened, that is smaller in size. Similarly, in the side view, this inclined surface is represented by this surface that is colored in the red color, and also in the side view, it appears to be foreshortened. So an inclined surface is represented as an edge in the front view, and in the other two views, that is in the side view and the top view, it appears as a plane surface, but it is not to the true size, and it is foreshortened. Now let's see how the three views are drawn for a given three-dimensional object. So this is a stepped block that is colored in various colors to indicate the front view, the top view, and the side view of the component. So I have a stepped block that are colored in different colors, and this is the direction that has been indicated for the front view, and this is the direction for the side view, and this is the direction for the top view. So if I observe from this direction, that is from the front, what I can see two plane surfaces that are colored in the pink color. So the front view of this stepped block is nothing but two plane surfaces that are colored in the pink color. So always the front view is projected on the vertical plane, and this is the vertical plane on which the front view is projected. So the front view consists of two plane surfaces that are colored in the pink color. So if I observe from the side view direction, that is from this direction, what will be the side view of this component? I can see three surfaces that are colored in blue color. This one surface, it is in the shape of L, and there are two other rectangles that are colored in the blue color. So what happens? This is the side view is always projected on the profile plane. So the left side view will be projected on the right profile plane, and the right side view will be projected on the left profile plane. So coming to this diagram, this object that I can see is from the side view. In this direction, if I observe the component, I can see three surfaces that are colored in the blue color. So this is nothing but the side view of the given stepped block, and this side view will be projected on the on the profile plane. In this case, what we are observing it from the left side, this will be the left side view, and it will be projected on the right profile plane. So what will be the side view of this object? It consists of three surfaces. One is in the shape of this is the one surface that is in the shape of L. So this is that, and also we can see two rectangles. These are the two rectangles that are colored in the blue color. So this will be the side view of the given component. Similarly, if I observe from the top, what I can see? Again, I can see three surfaces, this surface, and this surface, that are colored in green color. So the top view of this stepped block will be one surface that is in the shape of L, and the other two surfaces are rectangles that are colored in green. All these three surfaces represents the top view of the given component. So always the top view of the component is drawn on the horizontal plane, and this is the top view of the given component. So the top view is projected on the horizontal plane, the front view is projected on the vertical plane, and the side view is projected on the profile plane. So how do we draw the orthographic projection? So in first angle projection, always the area above the XY line represents the vertical plane, and the area below the XY line, it represents the horizontal plane. So in the vertical plane, we are drawing the front view of the component. In the horizontal plane, we are drawing the top view of the given component. And in this diagram, if I observe, this is the left side view of the component. So this left side view has to be drawn on the right profile plane. So this is the side view, left side view, that is drawn in the right profile plane. Okay, so this is the front view of the component, this is the top view, and this is the side view. So in first angle projection, always the top view is drawn exactly below the front view. The top view is drawn exactly below the front view, because the front view and the top view, they share the same width dimension. Similarly, the front view and the side view are drawn horizontally, and because the front view and the side view, they share the same height dimension. So this is how the three views of a given component are drawn in orthographic projection for a given three-dimensional object. So this is the front view, this is the top view, and this is the left side view that is drawn on the right profile plane. So let's see what are the steps that are to be carried out in order to draw the orthographic projection. So the first the step is, first you have to suppose if the direction is not specified in the given problem, which is the front view direction and which is the side view direction, you have to select the direction which indicates the maximum features of the object as the front view. Okay, then you have to decide how many views to be drawn. If it is not specified, usually three views will be drawn: the front view, the top view, and the side view. So the side view, it can be a right side view or it can be the left side view. First, draw the visible features of the front view, and after completing the front view, draw the projectors vertically downward from the front view to create the boundaries for the top view, because the front view and the top view will have the same width dimension. So draw the vertical projectors from the top view, from the front view, to create the boundaries for the top view. Then you complete the top view. So after drawing the top view, from the top view, project back to the front view and use the vertical projectors to fill in any missing, visible, or hidden features in the front view. So the next step is in order to draw the side view of the given component, what we are supposed to do? We have to draw the 45-degree projector lines in the lower right corner or on the left corner of the sheet. This is, we suppose, in the lower right corner in order to draw the left view of the given component, and also in the left corner in order to draw the right side view of the given component. And again, from the top view, draw the projectors over to the 45-degree line and up in order to create the boundaries for the side view, because the width of the side view is obtained from the top view. And again, from the front view, draw the projectors horizontally in order to create the boundaries of the side view, because the side view and also the front view, they share the same height dimension. So for that, you draw the horizontal projectors from the front view to the side view. Complete the side view. So project back to the front and the top view from the side view as needed if you want to show any hidden lines. And finally, draw the center lines wherever it is necessary. So these are the steps that are to be followed in order to draw the orthographic projection for a given component. So first we have to draw the front view. Then the next step is to draw the projectors from the front view to the top view and complete the top view, because the top view and the front view, they share the same width dimension. And then you draw the projectors from the top view to the side view, and also the projectors from the front view to the side view, because the side view and the front view, they share the same height dimension. So after drawing all the three views, show all the hidden lines in the front views, in the side view, as well as in the top view, and finally draw the center lines wherever necessary. So these are the various steps that are to be carried out in order to draw the orthographic projection for a given component. So let's see how to draw the three principal views for a given component. So this is the component that has been given. For this, we are supposed to draw the front view. This is the direction of the front view. This is the side view, and this is the direction of the top view. So if I observe from this direction, that is the front view, what I can see the front view is nothing but a trapezium of base length 100 and the top width is, this is indicated as 15 mm. This width is 15. In between these two, they have a slot of 30 mm. So this, the top line of this trapezium will be of 60 mm. So the front view, if I observe from this direction, the front view is nothing but a trapezium of base 100 mm, top line of 60 mm, and the height of the trapezium will be indicated here. It is 45 mm. And this trapezium, it has got a rectangular slot at the center of width 30 mm and height 25 mm. So this is the top view of the, front view of the given component. So if I observe from the side view, what I can see, this is the side view. The side view is nothing but a rectangle. This, the width of this rectangle is, I can see it here, it is shown in the top, it is 40 mm, and height of this rectangle will be the 45 mm. That I will get it from the front view. Okay, similarly, if I observe from the top, what I can see a rectangle of length 100 mm and width is 40 mm, and this rectangle has got a slot at the middle of 30 by 40 mm, and I can see these edges, okay, that will be seen in the top view. So the front view will be a trapezium, the side view is a rectangle, and the top view is also a rectangle for this component. So let's see how to draw these views in the sketchbook. So before drawing the front view, what are we supposed to do? We are supposed to draw two vertical lines, that is XY line and the X1, Y1 line. So the XY, the area above the XY line represents the vertical plane in this area. So this is the XY line. This is the area above the XY line represents the vertical plane, and the area below the XY line represents the horizontal plane in the first angle projection. So we are supposed to draw the front view in the vertical plane and the top view in the horizontal plane. So in this diagram, we observe, we are doing, this is the left side view. So we are observing it from the left side. So in first angle projection, the left side view is drawn in the right profile plane. So this is the area of right profile plane. In this area, we are supposed to draw the left view of the component. So we are going to draw these projector lines in this lower right corner in order to draw the projectors from the top view to the side view. So as we all know that all the visible lines, while drawing in the sketchbooks, all the visible lines will be continuous thick lines, whereas the hidden the dimensional lines and the projector lines will be the thin continuous lines, and the all the invisible lines are to be shown by the hidden lines. So the first step is to draw the XY line and another line X1, Y1 line perpendicular to the XY line. So the area above the XY line represents the vertical plane. Here we are drawing the front view, and the area below the XY line represents the horizontal plane, where we are going to draw the top view of the given component. And then this for this component, we are supposed to draw the left side view, that we are going to draw it in the right profile plane. Okay, so the next step is to, after drawing this XY and X1, Y1 line, we are supposed to draw the front view. So what is the front view? As I said, the front view is nothing but a trapezium of 100 mm and the height is 45 mm. The base length is 100 mm. The top length of the line is 60 mm. So first, in this area, in the front view, you draw a line of 100 mm and draw a line another draw another line parallel to this base line at a height of 45 mm. Okay, and thus now what we have to do, I can see this rectangular slot of width 30 mm and the depth of this rectangular slot is 25 mm. So in order to represent this slot, you draw a line. This width is 30 mm and this height is 25 mm. Okay. Now you erase of the extra lines because at the top I require only 30 plus 15 plus 15. So this is your 30, this is 15 and this is 15. Erase the extra line from this, join this point to this end and join this end to this end. So what is the front view? The front view is nothing but a trapezium of 100 mm base length and the top it is, this is 15 and this, the rectangular slot is of width 30 mm and the depth of the slot is 25 mm. Again this width is 15 mm. So this completes the front view of the given component. Now we are supposed to draw the top view. So in first angle projection, the front view is, the top view is drawn exactly below the front view because the front view and the top view, they share the same width dimension. So for that, you draw the vertical projectors from this point. From this end, you draw a vertical projector. Again, from this end, you draw a vertical projector in order to create the boundary for the top view. Okay. Now, you draw the base width is 100. We have created the boundary. It is 100 mm. So in the top view, what I can see, the top view is nothing but a rectangle of 100 by 40 mm. So complete this rectangle of width 100 mm. This 100 mm we have obtained it by drawing the projectors from the front view, and this width of the rectangle is 40 mm that we can, that is indicated in the view that is given, the component that has been given. So for that, first you draw a rectangle of 100 by 40 mm, and also in the top view I can see these edges. I have to draw this line, I have to draw this line, this line, this line, and at the center these two, the width of this is 30 mm. So from the all the key points, you draw the projectors from the front view. So for that, you draw a vertical projector from this end and complete this edge. So again, from this point, you draw a vertical projector and draw this line. From this edge, again, you draw a vertical projector. Again, from this edge, you draw a vertical projector. So this completes the top view of the given component. Okay. So the top view is nothing but a rectangle of 100 by 40 mm, and also with these small rectangles of 15 by 40 mm, 15 by 40 mm. And at the center, I have a rectangle. This rectangular slot is represented by a rectangle of 30 mm width, and this depth is 40 mm. Okay. The next step is to draw the side view of the given component. So what if I observe from this direction, this is the left side view of the component. So we are supposed to draw the left side view in the right profile plane. Okay. So the left side view is nothing but a rectangle of, what is this? The width is 40 mm, the height is 45 mm. So in order to create the front view and the side view, they share the same height dimension. Therefore, you draw the horizontal projectors from the front view to the side view. That is, from here, you draw a horizontal projector. Again, from this bottom line, you draw a horizontal projector to get the height 45 mm in the side view. Similarly, you draw the projectors from the top view in order to get the width of the component in the side view. So for that, from this end, you draw a 45-degree line, projector, horizontal projector 45-degree line, and project it upwards. Again, from this end, you draw a projector line to the 45-degree line and project it upwards and complete this rectangle. So this width will be 40 mm. That is, this width is 40 mm in the side view, and this height will be 45 mm. That we get it from the front view of the component. So complete this rectangle, and this completes the side view. And also, if you observe, this is the slot that is not seen in the side view. Okay, the rectangular slot is not seen in the side view. The base of the slot has to be represented with a hidden line in the side view. So for that, you draw a horizontal line from this end. From the front view, you draw a horizontal line to the side view and show it as a hidden line, since this base line is not visible in the side view. So this completes the three views of the given component. So in the front view, I have a trapezium of 100, height is 45 mm. This rectangular slot width is 30 mm and depth is 25 mm. Similarly, in the top view, I have a rectangle of 100 by 40 mm, and with these small rectangles that we can see it from the top. Okay, this are represented by these lines. Again, in the side view is nothing but a rectangle of 45 by 40 mm. So this will be 40 mm. This height will be 45 mm. This we have obtained by drawing the projectors from the front view as well as from the top view. And the base of this rectangular slot is shown as a hidden line in the side view. So this completes the three views of the given component. Okay. Now we have to draw the same thing in the AutoCAD. Okay. So for the same component, we are going to draw the three views in the AutoCAD. So first what we have to do, this is the AutoCAD screen. Once you open the AutoCAD screen, since you are already familiar with the AutoCAD commands, first you have to set the dimensions to millimeters and then you set the limits to A4 size, that is 297 by 210 mm. First you draw two perpendicular lines, XY line and the X1 Y1 line, and then you draw since we are supposed to draw the left side view in the right profile plane, in this corner you draw a 45-degree line. So this area represents the right profile plane, and the area above the XY line represents the vertical plane, and the area below the XY line represents the horizontal plane. So we are drawing the front view here, the top view here, and the side view of the component in this region. So since we are already drawn in the sketchbook, what is the front view? I have to draw a trapezium of 100 and the height is 45 mm with the rectangular slot. The depth of the slot is at a distance of 25 mm from the top, and width of the slot is 30 mm. So for that, what I'm supposed to do? First go to draw this 100 mm line in the front view, that is in the vertical plane. Either you can go to the draw toolbar and click on the line command, or you can type line on the command bar. So go to the line command, down the draw toolbar, click on the line. Okay. So click on the line, draw a line. The length of the line is 100 mm. So enter the length 100. Press the enter key. So I have drawn a line of length 100 mm. Now, in order to draw this top line, it is at a distance of 45 from the base. So I'm going to offset this line by 45 mm. So for that, I'm going to make use of the offset command. So either you type OFF or just type O. Okay. So O, enter, specify the distance to offset as 45 mm. Enter, select the object. So you select this object has to be offset and you indicate direction, whether you have to offset it on this direction or this direction. So you show the direction. So I've drawn two parallel lines of length 100 mm and the distance between these two lines is 45 mm. Okay. Now, so in order to draw this lines, okay, so I have to draw from this rectangular slot is of width 30 mm and the depth is 25 mm. So before that, I'm going to draw a center line. So for that, go to the line command, click on the line command. So from the midpoint of this line, you draw a vertical line. Okay. Now I have to show this distance from this edge, from the center line, the width of the slot is 30 mm. So to draw the rectangular slot, I'm going to offset this line by 15 mm this side and 15 mm this side. And again, from the distance from here to here, it is 15 mm. So I'm going to offset, I have to mark 4 points of distance 15 mm on 4 times on either side of the center line. So for that, I'm going to offset the center line by 15 mm twice on either side. So for that, make use of the offset command. Again, type offset, enter. You specify the distance to offset as 15 mm. Enter. You select the object. I'm going to offset this vertical line twice on this side and twice on this side also. Okay. Escape. Now, what I'm supposed to do? I am to draw this rectangular slot now. It is at a depth of 25 mm from the top. So for that, I'm going to offset the top line by 25 mm again. So for that, offset, enter, specify the distances. The distance I'm going to offset it by 25 mm. You select the object to offset and indicate the direction. Okay. Now, I have to draw this lines from this edge to this line. So again, go to the line command. Select the line command, join this point to this point. So again, go to the line command, you join this end to this end. Okay. Now you remove the lines that are not required. So for that, I'm going to make use of the trim command. Type trim or tr, enter. Okay, it is asking select the objects. So select the objects or you press the enter key again. Now we go on selecting the objects to be trimmed. I want to trim this line. This line is not required. So again, in this center, this line is not required. You trim off all the lines that are not required. So remove the extra lines that have to be deleted in the front view of the component. So trim the lines. So for trimming, we are going to make use of the trim command. Either you select it individually or create the fence in order to delete. Again, the lines that cannot be trimmed can be deleted. So for that, I'm going to select, I don't want these lines. These are the extra lines. I'm going to delete these lines. Okay. So for that, select the line and delete it. Again, I have to trim this line. So for that, tr, enter. So trim this line. This is not required. Again, this line is not required. So the lines, this I cannot trim. So for that, you select this line and press the delete key. So this completes our front view. Okay. Now, so to draw the top view, what am I supposed to do? I have to draw the projectors from this end and again from this end. So for that, you go to the line command and the draw toolbar. So draw a line from this edge. Okay. So instead of going to the line command again and again, I'm going to make use of the shortcut key. So press the space bar twice. So this command, the previous command will end and the next command will be taken as the previous command itself. So I'm going to press the shortcut key, that is the space bar, twice. I'm going to draw the line from this again. Okay. Now press the space bar twice. Now I am going to draw a horizontal line. The top view is nothing but a rectangle of 100 by 40 mm that we have seen in the sketchbook. So to draw that, you draw a horizontal line here. Now I am going to draw the width of this. In the top view, it is 100. This is the 100 line of 100 mm. We have created the boundary for the top view by drawing the projectors from the front view. So from this end to this end, it will be 100 mm. I have to draw another line at a distance. The width is 40 mm in the top view. For that, I have to offset this line by 40 mm. So for that, offset, enter, select the distance. Enter the distances. I have to offset this line by 40 mm. Enter, select the object offset. So this is the object to offset. Now trim off the lines that are not required. So TR is to press the enter key twice to trim off the lines that are not required. So I'm going to remove the extra lines that are not required. So trim the lines, either you can create the fence or you can delete the lines individually. So now, so what else I can see in the top view? I can draw these edges, this edges and this edge and this edge. So for that, I'm going to draw the vertical projectors from the from the front view to the top view. So for that, go to the line command, click on the line command. So I have to draw the projectors from this edge. You draw a line. Okay. Press the space bar twice. So again, from here, you draw a line, space bar. Again, from here. So you draw the projectors from all the key points in the front view to the top view. Now again, you delete the lines that are not required. For that, I'm going to make use of the trim command. Trim, enter, enter. Now you delete the lines that are not required. Okay. So either you can create the fence or you can delete the lines individually. So you create a fence and delete the lines individually. So this completes. So this completes our front view and also the top view. Okay. So all the visible sides should be white in color. So for that, I have to change this to white. So for that, either I can create the layers before starting the drawing. You create the layers for different line types like center lines, the dimension lines, drawings, hatching, hidden lines, or you can do the match properties, or sorry, you can change the line type by making use of the change command. So for that, either you change the line type by making use of the layers or with the help of the change property. So I'm going to make use of the change property command. Type CH. Okay. Change. Sorry, before that, you select the line whose line type has to be changed. Then you type CH. Okay. Here you change the color. I'm supposed to make it white. So for that, you click on the white. Now you press the enter key. You close this dialog box. So all the visible lines should be white in color. So I have changed this line to white. So I have to change all the visible lines. All these are visible lines in the front view as well as in the top view. All these lines are visible lines. So I have to change this to white. So for that, what I'm going to do, I'm going to select this and then I'm going to do the change property. So for that, they have changed the one line, I'm going to do the match property for the remaining lines. So for that, you type the command match property, MA, enter. Okay, select, this is the, it is asking select the source. So this is the source, it is white in color. Now you select all the destination points. Okay. Okay. Otherwise, for this, in order to change, I'm going to select the entire top view, go to the layers, click on the drawing. So the entire thing will become, all the visible lines are white in color now. Okay. The next step is have to draw the side view for this component. So for that, I have to draw the projectors from the front view as well as from the top view. So for that, go to the line command. Okay. So draw the projectors from here to the 45-degree line, space bar, again from this here to the 45-degree line. So again, you draw the vertical projectors upwards. Again, you project it from this point to upwards. Again, you draw the horizontal projectors from the front view. Okay, not because the front view and the side view, they share the same height dimension, and the top view and the front view will share the width, same width dimension. Now you remove the unwanted lines with the help of a trim command. For that, you type trim and then enter. Now you remove the lines that are not required. So I'm going to trim off the lines that are not required. So trim the extra lines that are not required. Now trim, enter, trim the lines. Okay. Now this also should be white in this entire surface is visible. So for that, I have to change this line type to white. So for that, you select this. Either you do the match property or you select this. Go to the layers, click on the draw. So this completes the side view. So one more thing, in the side view, I have to show this, the base of this rectangular slot as a hidden line. So for that, I have to draw a line from here to the side view. So go to the draw toolbar, click on the line. So from this point, you draw a line to represent the base of this rectangular slot as a hidden line in the side view. Now you trim the unwanted lines, trim, enter. So you trim this line. So this line you select it and you delete this. Now this should be the line type of this line should be a hidden line. So for that, what I'm going to do, you select this line, go to the layers, you click on the hidden line. Okay, I have changed this to the hidden line type. Okay, so here this completes the three views of the given component. So this is a front view, this is our top view, and this is our side view. So let's do the dimensioning. Go to dimension, click on linear, you select the points. Okay, so you dimension all the whatever you want to dimension. So select this point, again go to dimension, click on linear. Okay, so dimension linear, so from here to here, again dimension linear. So if I want to dimension linear, dimension, go to linear, again to indicate the depth of this rectangular slot, dimension linear, etc. Now we have done the dimensioning, but we are not, this text, the dimension text is not visible. So for that, you select any one of the dimension. Okay, then you say ch change property, enter. This dialog box will open. Here you go to the text style. Okay, in this there are various options. Standard, Romans, Roman. You click on ROMAND. Okay, press the enter key. You close this dialog box. Okay, so now the text is visible. So I'm going to do this match property for all the other text dimensions. For that, type MA, enter, select the source object. This is my source. Now you select all the destination objects. Okay, so now you select all the destination objects. So we have done the dimension. So make use of the pan command if you want to move the screen. Okay, now we have drawn the front view, the top view and the side view. As also we have dimensioned all the required things. So also if you want to show this, extend this lines, I can show the projector lines. So for that I'm going to make use of the extend command, EX, enter, show the boundary. Have to extend up to these lines. Again press the enter key, select the lines to be extend. Okay, again I can extend these lines also. So for that what I'm supposed to do, type EX, enter, this is the boundary, enter key. Now you select the lines that has to be extended. Okay, similarly if I want I can draw this lines. So for that I'm going to draw a line from this point to this key point in order to show the projector lines. Again from this point to this point to show the projector line. So this completes the three views of the given component. This is the front view, this is the top view, and also we have drawn the side view. Then we have shown the line type. The hidden lines are shown with the hidden invisible lines are shown with the hidden line type, and also we have done the dimension. So this completes the exercise. Thank you.